This video will cover loading data from binary data files. The code used in this video is available in the Learning Management System. This video will use data from the data file weather2017.xlsx. You should download these now if you'd like to follow along. By the end of this video, you should understand what a binary data file is and how you would load data from Microsoft Excel into R. So far, we've covered loading data from text data files, but these aren't the only way to share data. Some data are available as binary files. And R has the ability to read some, if not most, binary file formats. Binary file formats have some big advantages over text files. The data files are usually smaller, the data frequently loads faster, binary files often explicitly define things like variable names, data formats, and data types, so your software doesn't need to guess at them when it's attempting to load the file. Further, binary data files store information in the way that's native to computers, so they don't need to convert numbers between their binary and base 10 representation as they're loading them into memory. There are some downsides to binary files. Binary file formats can be proprietary, and what this means is it's a file format that's used by a specific piece of software, and only that software can read those types of files. Second, binary file formats may be obscure. Since they're not human readable, it can be difficult to discern the information inside of them, or even tell which program created them, which can make it difficult to then load them. Additionally, not all programs can read all binary file formats. R is pretty good. There's a wide variety of libraries that allow it to read many different binary file formats, but there may be some binary files that you're unable to read. Lastly, binary file formats can change over time. For example, Stata, a popular commercial data analysis software package, changed the format of its binary files in versions 9, 10, 12, 13, 14, and 15. You have to know the correct version to correctly import the file. So someone using R, or even an old version of Stata, might not be able to read the newer data files. Just like this VCR or this DVD player, as time passes, binary files might be unreadable. There is one incredibly common binary file format, and this is Microsoft Excel. These files usually have .xls or .xlsx extensions. These are rectangular data stored in separate spreadsheets. This is the de facto standard for business spreadsheets, which has made it a very popular format for storing data. While Microsoft Excel is a common format for storing data, it should come with a warning. Microsoft Excel is a spreadsheet, not data analysis software. It's not a great format for storing your data. Excel does not require the data in its spreadsheets to be tidy. This means that R still has to guess if columns contain texts or numbers. You also may need to tell R about the boundaries of data in a worksheet. On top of that, Excel sheets might not even be rectangular. There's a feature in Excel that allows you to merge cells, which violates the rectangular paradigm. Lastly, converting dates in Excel can be problematic. It has its own way of storing date and time information, which may not be compatible with other software. In previous videos, I've mentioned that data readers in the tidyverse, with the read underscore and then the type of data file, usually have a corresponding write function. As it is implemented right now, there is currently no write underscore Excel function, so you can't use R to write Excel files. You can use R, however, to read Excel files. You're going to read them with a function called read underscore Excel. It's part of its own package, the readxl package. This is not loaded with the tidyverse, so you're going to have to load this package every time you want to access a Microsoft Excel file. Excel files come in two formats. There's the older XLS version, which are binary files, and there's a newer version, XLSX, that are actually XML-based files. readxl can read both of these. It's going to determine the file type using the file extension. There are two analogous functions, readxls and readxlsx, which assume you give it the correct file type. You'll frequently need to provide additional information when you load Microsoft Excel files. You'll do these through additional named arguments to the readxl function. So for example, sheet equals identifies the worksheet to read, which you'll put in quotation marks. Range defines a range of cells to load. Only the start part is required. If you don't provide an end, R is going to read as far down and to the right as it can. You specify start and end with the typical Microsoft Excel row and column references, so letters for columns followed by a number for the row. The nice thing about readxl is that other readr options like col names, NA, skip, nmax, and guessmax all work with readxl in the exact same way that you would expect. There's also an additional function, Excel underscore sheets. If you feed an Excel file to that, it will give you a list of sheets in the file. So I have some sample code to work through reading a Microsoft Excel file. First, I'm going to load my setup code. Remember, as I have on line 11 here, if you're going to read an Excel file, you need to explicitly load the readxl library. So I'll run this setup code. Second, because we're going to deal with the same Excel file several times, I'm just going to save the full path and file name to a variable called Excel file. Before I try loading this file in R, I'm going to take a look at it in Microsoft Excel. So I've opened it up here, and what you can see is there are two worksheets in this spreadsheet, one named College Park and one named Davis. The College Park sheet has data in the first 4 columns. There appear to be variable names in the first row with date, temp F, RH, and wind speed, and then data below. I can take a look at the Davis sheet. It appears to have a very similar format, again with variable names in the first row and data below that. Before I load this spreadsheet, I can take a look at the sheets that are in it. Again, I do that using the Excel Sheets function. I'll run that right now. And you can see it prints out a vector with the name of the 2 sheets that we saw in the spreadsheet, College Park and Davis. So now I'd actually like to load some data from this spreadsheet. Again, I do that using the read Excel function. I feed it the name of the file, which I've stored in a variable, and the sheet that I would like to load data from. Because there's more than one sheet, it's important that I specify this. I'll load from the College Park sheet first. I'll do that now. I don't save it to a variable, so the result just prints out to the console. And what you can see is there's a couple of warning messages down at the end. There are actually some data that R was not able to read because where it was expecting a number, there was actually a little bit of text. But otherwise, scrolling through this output, you can see that it properly loaded the date, temp F, RH, and wind speed columns, and I have a tibble with 25,027 observations and 4 rows. Going back to my code, I can do the same thing with the Davis sheet. I just changed the sheet option to Davis. I'll run that piece of code. Again, I get very similar output. There are a couple of cases where R couldn't read data because there was some text mixed in, but otherwise, scrolling through the data, you can see that it looks very much like what was in the spreadsheet. Going back to my code, Read Excel offers many options for customizing exactly what's loaded from the spreadsheet. An important one is range. Again, Excel spreadsheets don't always contain tidy data. People might put additional information outside of the rectangular piece of data that you would like to load. You can specify a cell range using the standard Excel format of specifying columns with a letter, rows with a number, using a colon to separate the starting and ending point of the range. So what I have here is I'm telling R to load cell A1 through cell C100, which means it will load the first 3 columns and the first 100 rows. I'll run that piece of code. Taking a look at my output, you now see that it has only loaded 3 variables, the first 3 columns in the dataset, and only 99 rows, because again, the first row contained the variable names. There are readers for other types of binary files. The Haven package provides functions like read_DTA for reading Stata DTA files, read_SAS, and read_XPT for reading SAS files. The Feather package provides read_Feather for reading data files that were saved by Python. I'll caution you that Feather is still under development, and so the file format could change, and just like I warned you, may become obsolete. There are many other data file formats. R has libraries that can read many of them, but possibly not all of them. So some big takeaways for dealing with external data. readr and other packages provide readers for many different file formats. Consistent with the tidyverse, the options for these are consistent across functions. Things like col names, col types, and guess max all work consistently across all of these file readers. Likewise, most of the read functions have a corresponding write function that allows you to output files in that data format, with read Excel being the notable exception.